All right, sweet. So this is a good question to kind of start with. I don't know if you got a chance to review these at all, but we can start with this one. Do you want to, I can give you like a couple minutes to work over it, and then I can swoop in and show you how it's done afterwards. Does that work for you?
Yeah, I did work on it right before this meeting,
Okay, perfect.
so
Awesome.
I got as far as I could, and then I got stumped.
Okay. What do you think the answer is here?
Well, I'm not really sure.
Cool. So that's going to happen on the test too, right? There's going to be times
Right.
when you don't know the answer. So what you want to do at that point is take your best educated guess. So given the work that you did, which one do you think is going to be the best answer? And if you're right or wrong, it doesn't matter. We'll go through and solve it, but just give it your best shot.
Looking at my work, I would probably say 18.
18, cool. And I think a lot of students pick 18. All of these are set up to try and trick you, right? 22 actually turns out to be the right answer, but that's okay, right? It's cool because you're here learning, so we can grow from here. Now, let's get started with you telling me about how you got to your answer. So, what did you try to do?
Okay, well, I've got oh, well, shoot, yeah, I got the equation. 3ab plus 2b to the power of 3.
Hmm.
Then if a is 1, I did 3 within the parentheses, 1 times 2,
Okay.
close parentheses, then plus 2, parentheses, 2, closed, then the 3 exponent.
Nice. This is off to a great start. So now the issue that the mistake you made is definitely going to be exponent related, more likely than not. But let's go through and what would you do next? Or is this as far as you got?
Well, what I would do next, I try it two different ways.
That's
Uh,
good.
I did the parentheses first.
So you're following your PEMDAS, right? That's the one you mentioned. This is your
Yep,
order of operations. So inside of the parentheses, there's this, 1 times 2. Then there's also this.
right. So after that,
What'd you get?
so I got 2, then I brought it down
Good.
with the 3, then
And what did you change this? Did you change this too or no? Leave it the same.
no. I did something different on my other equation because I tried it both ways. I On the second one I tried 3 times 1, then
Okay.
I did 3 times 2.
And what, so 3 times 1 gave you just 3, right? And then you times
Right,
it by 2.
right, then that gave me 6.
Okay. And that gives you 6. And then what'd you do? So, and notice, right? Over here it gives you 6, and over here it should give you 6 as well, right? You're still left with a 3 times 2. And so
Right.
it doesn't matter. What's cool about it's called the cumulative property. It doesn't matter which order you do multiplication in. 3 times 5 is equal to 5 times 3. So 3 times 2 times 1, or 1 times 2 times 3, or 3 times 2 times 1. Doesn't matter the order of those three numbers. As long as you multiply each one at a time, you should be fine. You should come up with 6.
Okay.
So that's good. So we're so far so good. But the big issue here is going to be this guy, right? How do we solve
Right. Well, what I did the 2 times 2, which gave me 4. Then I
it?
just did 4 to the power of 3.
And that gave you 12.
It did not, no.
Good. It did. It shouldn't. 4 to the third power does not equal 12. So that's great. That's actually good.
I got 64. If
64. And 64 is correct. 4 to the third power does in fact equal 4 times 4 times 4. And again, we would just do it one at a time. So you get 4 times
Right.
4 is 16 times 4 equals still 64. So great work. You just did it in the wrong order, right? If you do
Right.
2 times 2, that's doing multiplication before exponents. And so you got to make sure you're doing exponents before multiplication. Is that
Okay.
cool?
Yeah, it's starting to come back to me from high school.
Cool. No, you're great,
Yeah.
man. I mean, I'm surprised you got 4 cubed on your first try. Honestly, I think most students would forget what 4 to the third power is. So that's a good sign. But given now that you don't want to turn this into 2 times 2 is 4, you actually want to do, I'll do it in blue, 2 to the third power. First, what is 2 to the third power?
6, right?
So 4 to the third power, you did know was 64. 2 to the third power, therefore, cannot be 6. What is 2 to the third power expanded? If I were to write it in a simpler way, how would I write 2 to the third power?
2 times 2 times 2.
Perfect. And what is 2 times 2 times 2? So just do them one at a time. Very good. 8 is the right answer. So this blue portion then becomes 8. And then we'll do right here. And so you're actually set. Now you can go through multiply and then add. So remember, don't add first, right? Because that's not in this order of operations. You have to multiply and then add. So from here, what's the next step, do you think?
Sorry, just 1 second.
Yeah, take your time, no rush.
Okay, sorry, could you repeat that last part?
Yeah, what is the next step from here?
So 2 times 8,
Which is?
16.
Very good. And now last step. Add. And if you like, this is where I would encourage you to write it. Like if you're not sure, definitely write.
That's just what I was doing.
Perfect.
So, 22.
22 is the right answer.
So
Perfect.
y would equal 22.
Y would equal 22. Very good, very good. So you have the skills now, right, where you can call back into your algebra experience, right? You know that the answer is technically y equals 22, not just 22. But the goal here is going to be focusing on more of the questions, right? The mistake, well, I did hear one mistake that I want to point out to you. You said that you do this first because it's parentheses. And you would be right if it was inside of parentheses, but what is all that's inside of that parentheses is just an 8.
Right.
And there's nothing you can do to that 8 because there's no operation in there. Now, if there's something in there, you can do it first. So why do you do this first? If it's not because of parentheses, it's because what?
To multiply.
Because it's multiplication. Perfect. Great. Great job. And so getting specific, right? Because I know that sounds like a very small difference. You're like, I said it's parentheses, but I meant multiplication, which obviously you did because you multiplied it right anyway. So it's not that big of a deal. But paying attention to those small differences is going to be what keeps you from picking these other answers. All of these other answers are based on you making some sort of a mistake.
Okay.
That's their goal. Like you can see pretty clearly here. Let's see if this works. 3 times 1 times 2 plus 2 times 2 to the third. The mistake that everybody's going to make here is they're going to think that 2 to the third is 6. That is not true. So this test is checking, do you know what exponents are? So when you go through and if you do it wrong, 2 to the third being 6, which is incorrect, you get 12 plus 6, which is 18. And so they want you to make a mistake so that you pick that wrong answer. And so when you're really good at this test, when you're ready to crush it, you're going to know the mistakes that they're trying to get you on. And so you can avoid those.
Okay.
So let's try this one more time, a little bit faster. 3 times 1. I'll substitute it in for you. And you're going to talk me through it real quick. Go ahead. It's all good, man. I'm not gonna chew you out. I just talk fast because I want to make sure that we're filling this time with as much help as possible. So if you make a mistake, it's all good. Like this is the time for it.
Right.
So what am I gonna do next?
Bring down the 3
and
multiply 1 times 2.
Okay, that's fine. What about on this side? And technically, you shouldn't even do that first because because multiplication comes after which part? What am I going to say we should do first?
Exponent.
Of course, right? So exponents is what we should be doing first. These parentheses have nothing going on inside of them. So there's not really any parenthesis work to do. So what we should start with, just so that we get, again, this is very technical, if we're doing it properly, the first thing we should do is exponents. So what do we do if we're doing that?
The 2 to the third power
Becomes what?
8.
Very good. And now we can start doing PEMDAS, right? So parentheses, we ignored it. I literally just got rid of them. So because there's nothing inside of them.
Right.
Exponents, we just did. There's no more exponents. So multiplication and division, what's the next step?
Let's multiply.
Very good. So go ahead and multiply these out.
So the 3 times 1 would be 3, then
Mm-hmm.
2 times 8 would be 16.
Very good. So I got over on this side.
Right. Then that
Go ahead.
3 times 2 would become 6.
Very good. And now is there any more multiplication?
No.
Cool. Is there any division?
No.
How about addition and subtraction?
Yes.
Okay, go ahead and subtract it or add it.
So we'll add 6 plus 16, which becomes 22.
Perfect. Cool. Any questions on this question? This is a good one for you to understand thoroughly because there are some basic fundamental building blocks in this question that
Right.
apply to many questions. But not bad. Knowing to substitute this in is a huge first step. Knowing how to properly do exponents is a huge other step. So this test is checking to see, do you know those parts? All right, cool. I love these series questions because I think they're really easy. I think most of the time, if you get these wrong, it's because you're overthinking. So go ahead and give this one a shot.
Okay.
Do you need a pause? I can give you a pause if you need
Yeah,
it.
I'm just putting my phone on silent. So I didn't get too far on this one, but I want to say I think I got a good start, but I also want to say I think I found the answer a different way.
Okay. Here, I got one call coming in. I was hoping it wouldn't come in at this time. So I'm gonna just put you, I actually am gonna pause it real quick, okay? I'll be right back with you.
Okay.
All right. All right, so go ahead. Tell me how you did this one, because you said were able to do it a little differently.
So I tried to do it after one of your lessons on the website
Mm-hmm.
is, the average. And I did 1 plus 10 plus 7 plus 6 over 4.
Cool. This is 16.
16, yeah.
Cool. Nice. Not bad. And what do we get? 18 plus 16 is 30. I shouldn't do it like that. I should write it out. It's a good habit. 34 divided by 4. Put the top one inside and then put 4 outside and then see how many times 4 goes into 34. Goes about 8 and a little bit more. 8.5. Is that what you got? Okay. This one's definitely not asking about averages, right? This one's a series, right? And so series is going to be like music is what you want to think about here.
Right.
Go ahead,
Another,
tell me what you got. Go ahead.
oh, sorry. So I pretty much got the same answer except the little extra part. Yeah, just like that. But I noticed that 1 and 10, are 9 apart. Same with 7, 16.
Perfect.
Then when I counted 9 numbers from 7, I got 13.
Nice. That's a good way to do it. So 1 to 10 is, you said you counted, how did you do it exactly? Say one more time.
Well, I counted 1 to 10, right? Then I
Mhm.
counted from 7 to 16.
And what is that?
Just, 10 numbers apart.
Well,
Depending on
not.
how you get right.
Yeah. And so that's the series, right? It should be like music, right? Music is all repeating. So it's all about
Right.
that pattern. So +9 is half of the pattern. What's the other half of this pattern? It's going to be this part right here.
3.
Up or down? Up, it would be 13, right? If I started at 10, went to 7, would I go up to 13?
No. Sorry, I gotta
You're good. You're good. Take your time.
find a blank piece of paper.
Yeah.
So if it would go up or down between 10 and 7,
Mm-hmm.
probably down.
Yeah, for sure. If you had 10 shirts and now you have 7, do you have more or less?
Less.
Of course. So it has to go down 3. And that is the missing piece. Once you have those 2 steps, you can get the answer very easily. So plus 9 down 3, up 9 down 3. And so what's going to be the number here?
13.
That's right. 13 is correct because we went down 3. And I think you said 13 earlier. You got the right answer. So trust that intuition for sure. But showing it is key, right? Once you can show it and explain it to yourself and others, you have a better chance at all the other questions.
Right. And I think that's the big thing for me for ASVAB is going through high school with a calculator, but not being able to do it
On paper.
on paper or in my head, and
Yeah, I mean, the only way to get there though, bro, is practice. Like there's only one way, right? So definitely continue to struggle with it. I know that you're using Khan Academy. I know you're using other things. So just keep practicing. If you stick with it, you'll get better. As long as you stick with it, for sure. And
okay.
so if you look at these numbers, none of this is calculator needed, right? Like
Right.
adding 9, subtracting 3, you can do that on paper all day long. It's when you get to like higher numbers that it might get a little bit harder. But these 3 questions I picked very intentionally because they're a little bit simpler, right? There's not going to be any reason for a calculator if you know 3 times 1 and 2 to the 3rd power. And you did. I mean, you knew 4 to the 3rd power, which is way harder than anything that you see in this question. So keep that in mind. All right, last one. Go ahead. Were you able to get this answer? Do you know the trick? This one's just like a trick.
I'm not really familiar with the term factorial,
Mm-hmm.
but I would assume, it means factors of 5.
Okay.
So, 5, 10, 15, 20, and so on.
Cool. I like that. Go ahead.
So I would say my answer was 10
10. Cool. Not
for
bad.
that.
Yeah, 25. All of these are actually factors of 5.
Right.
So let me show you what factorial means. So the other way that it's written is like this. So anytime you see that exclamation point, most students are going to freak out. They're not going to know what to do. So you can just write factorials.
So 5 with an explanation point would mean factorial. Is
Yep.
that right?
These two mean the same thing. 5 factorial and 5 factorial.
Interesting.
Cool. And the trick for these is anytime, let's say we had 7 factorial. That's going to be 7 times 6 times 5 times 4 times 3 times 2. And then you can times it by 1 if you want to, but anything times 1 is just itself. So there's really no point, but if it helps, go for it. So what would 5 factorial be now, given that answer?
So looking at how you did the 7.
Yep, just take this pattern and now apply it to the 5.
Right. So would you multiply all those together?
Uh-huh. Yeah. So
Okay.
7 times 6, 42, 5 times 4, 20, 3 times 2, 6, and then just continue to multiply. 40 or 20 times 6 will do 120. 42 times 120. So the answer is 5,040 for 7 factorial. But what's the answer for 5 factorial?
Okay. 120.
That's exactly right. That's it. And so that's the only trick with these. You might see it. If you see it, be like, yes, easy answer, because that's kind of how you want to feel. And that's how you want to feel on every single question.
Okay.
Yes, I know exactly what to do. Any questions here?
Yeah, looking at the one for the 7 factorial, when you've got 120 times 42.
Mm-hmm. I rewrote it up here to make it a
Right.
little easier.
So what's the rest of the steps after that?
Oh, sure. Yeah, I can show you that. So I'll start it on a new piece just so it's easy.
Okay.
That part, are you good with this? Do you have any questions on that?
No.
Okay, cool. And so first thing you're going to do is start with the ones place, which is going to be here, and then move out to the tens. So
Right.
this is 2 ones, and this is like place value. This is like grade 3 stuff that usually isn't taught that well, right? So it's really important to understand this is 4 tens, which is 40, and this is 2 ones, which is 2, right? 2 ones make 2, 4 tens make 40. And so now you just go through, you start with the ones. 2 times 0 is what?
Is 2.
Nope. What's 2 times 1 then?
0.
Yeah, 2 times 0 is 0. Very good. And what is 2 times? And now you continue, make sure that the 1 knows every single person up here. So 2 times 0 is in the ones place. 2 times 2 is now multiplying by a tens place. What's 2 times 2?
4.
4. And so I'll do this one in blue. And then 2 times 1, which is now in the hundreds place, I'll do that in red. What is 2 times 1? Now, we've done everything with these ones place. Now we're going to switch over to the tens place, which is the 4. Now it's important to note here, this is a 10, right? So what is 40 times 0? What's 4 tens times 0? Anything times 0 is always going to be 0. Even if it's a billion times 0, it's 0. But it's not in the ones place here. It's got to be in the tens because this is a tens place. So we actually shift over here. All right. So 4 times 0 is 0 tens. What's 4 tens times 2? What's 4 times 2?
4 times 2?
8. Very good. 4 times 2 is 8. And notice I did it in red because that's the hundreds place now. This is tens times the tens, which is going to give us another shift. All right. And now we do tens times 100. And so that's going to be a whole nother color. It's going to be 1000 or 1000. Well, it's 4 times 1?
4.
4. And now you just add these up. So 0 plus nothing is 0. What's 4 plus 0?
4.
Good. Next one.
10.
10. Now this is important. You asked about this in your text message way back when. This is similar to, I thought you did, borrowing numbers. It's the reverse though, because it's addition. So here, when we add these two, 10 can't exist here, right? I can't write 10. I have to use the next over. So it goes 0 and then add 1 over here. And then last step is going to be 4 plus 1. And what is 4 plus 1?
5.
5. Very good. And now there's nothing left. So the answer is 5040, which is the answer I got, right? That's how you know you're doing it right, is if you're getting the same answer every time you do it, it means you're probably right. So 5040.
Right.
Do you want to practice some more of these?
Yeah, because I'm not really familiar with the, the 0 times 2, then the 2 times 2, then the 2.
Cool.
The 1 times 2, and so on.
Here, so we'll do easy numbers. We'll do 44. We'll do less than 5. 43 times 21. All right, I'm going to give you a couple minutes. I want you to try your best. All right, go ahead and work through this one and then tell me when you're done. I'm going to time you because just so you know, every question you do on the math knowledge should be about 1 to 2 minutes.
Right.
Ready, set, go. You're at 1:30. You're still doing good though.
Is
I'm going to tell you right from the jump that this doesn't sound right to me. The reason is if we said 40 cents times, we'll say 2, that would just be 80 cents, right?
Okay.
So now 40 cents times 20, which is a little bit closer, well, that's got to be 800 cents. So if we look here, it's got to be more than 800. You want to try again before I go through?
Would it be 8,643?
These are very big, these are different numbers, that's for sure, right? So I don't know. I don't know for sure. I think you're right. The reason I think you're right is because 3 is right. 1 times 3 in the ones place is 3, and so it should be in the ones place there. So let's go through. We can check real quick. Doesn't take too much time. So 1 times 3 is 3. 1 times 4 is 4. And then we shift because we're now using the tens place. 2 times 3 is 6. 2 times 4 is 8. And then you add those up. And this is where you got the mistake, right? You kept them.
Oh, okay. I see how you did that. So okay, the tens.
So you are close, but last step, you got to add those together. Go ahead. Tell me what the right answer is for this question.
So when you do the 2 times 3, then whatever the answer is, that would go in the tens place under the 4. Okay.
What they say is you shift over every time you're using a higher magnitude. The ones place, you start on that right side. But once you're in the tens place, you got to shift over to the tens place. Once you're in the hundreds place, you got to shift over to the hundreds place.
Gotcha. I got 903.
903 is 100% correct. Smiles, stars, gold stars, all that stuff, okay? This is the way you multiply numbers, all right, from here on out. You ready to try another one?
Yes.
All right, let's do bigger numbers. 56 times 47. Now, this is going to have a whole bunch of new challenges because it's going to be much bigger numbers. There's going to be a lot more carrying. All right.
Right.
So give it your best shot. I mean, actually, let's try another one, another easy one. Let's do 34 times 21. Is that what I did? There we go. Let's do 34 times 21 first, and then we'll do 56 times 47 at the end. That'll be the last question.
Okay.
Oh, I should have timed you. Dang. And go.
Okay. I got 714.
All right, 714. Let's verify. 4, 3, 8, 6. That looks like 714 to me, man. Great work. Any questions here?
No, I like this way than what I was taught at the local college at the math lab. It makes a lot more sense.
Good. I mean, you're doing it right. So as long as you're doing it right, you're fine. Now,
Okay.
this one's going to be a new challenge. So I'm going to do this one with you, and then I'll give you your own afterwards, okay? So
Okay.
you tell me step 1, 7 times 6. What is 7 times 6?
42.
Very good. 42 is correct. You got to get faster with it, but I'm not upset about that. I'm happy you got the right answer. So here's important. You carry the 4, all right? You're not multiplying with that anymore. You can't just put, just like I said earlier, you can't just put 42 here in the ones place. It doesn't make sense. There's a 10, right? So you got to throw that 4 up into the tens place, and then you add it after you multiply the next question. So the next question is what?
7 times 5.
Very good. So we're still with the ones place, but we have to multiply by the next number. What is 7 times 5? Everybody loves their 5 times tables.
Yeah. 35.
35, right. But there's this 4. So you add, because it's 4 tens, you add that to the 35. And what do you get?
9.
39. Very good. And you can carry this 3 into the hundreds, or you can just write it down. You don't have to do anything crazy there. So 392. Questions there? That's just the ones place. Now we got to do the tens place, the 4.
Right. I do have a question, but I can save it till later.
Perfect. That's fine. That's fine. Let's do the 4. What is 4 times 6 first?
24.
24. Now, I can't put 24 like this. I put the 4 down, and I carry the 2. Where am I going to carry that 2 to? Put it over here. I put it the same place where I put the 4 last time I carried. All right. Next step. What's the next step?
4 times 5.
Perfect. What's 4 times 5?
20. And plus the 2 would be 22.
Perfect. Great job. Plus 2 is 22. All right, go ahead. Add these two numbers together. Tell me what you get.
2,612.
Yeah, I don't know. Let's see. So 2 plus 0 is 2. 9 plus.
I see my mistake.
All right. Go ahead and fix it.
2,632.
All right, 3, carry the 1, 6. Good. I'm good with that. Great work. Questions here. Now you can, I know you were saving a question, so did you want to ask that now?
Yes, so where is it? When we did the 7 times 6 numbers, that aren't even, sometimes can get to me, like when I see 6 times 7,
Mm-hmm.
it's add 6 7 times. So yeah, I'll write it down, and
Or
yeah, with a less that's what I did. The 7 times 7 times 7.
7 times 6.
Right.
Yeah.
But when I write it down, I'll add them all together.
Mm-hmm.
Then I usually do 2 at a time. So 7 times 7, 14, and 14, 14. Then I add the 14s. Then I get 28. Then I add the last 14. Then I get the 42. Yeah, just like that.
Cool. That's fine. I mean, bro, the real way that you should do this, right? The way that a math teacher would tell you to do this, you got to memorize. 6
Right.
times 7, 7 times 8, 8 times 9. Those 6, 7s, 8s, and maybe 9s are the tough ones. But after that, it's back to 0, right? And multiplying by 0 is easy. Multiplying by 1 is easy. So getting memorized with your 6, 7s, and 8s is going to save you a ton of time. But you still got 42, and 42 was right. So however you're doing it is okay. It's just going to take a lot more time if you don't have it memorized.
Right. So what would be more better and efficient way of doing this?
Yeah. The fastest way to do your 6 times tables, let's say 6 times 3, is to think of 6 as a 5, right? If you don't have it memorized, you think of 6 as a 5 because everybody loves their 5 times tables. That's 15, but now you have 1 extra. So now you add 3 and you'll get that 18. So you think of the 5s and then add whatever's missing. That make sense?
Not really, no.
All right, so 7 times 8, right? Obviously, this is one that you struggle with, right? Fair enough.
Yes.
Cool. Everybody struggles with 7 times 8. You're not alone. The easy way to do this one is think, what is 5 times 8?
40.
40. And how many 8s am I missing if I'm only doing 5? How many more 8s do I need? How many am I missing?
7.
Well, I need 7, but I got 5 of them. How many more? How many more 8s do I need? I got 5 of them. I want 7 of them. I
Oh,
got 5
2 more.
shirts. I want 7 shirts. All right, cool. 2 more, right? So now you're just gonna do 2 more 8s. And what's that?
14.
2 times 7 is 14. What's 2 times 8?
16. I see what I did wrong.
Yep, 16. And so now you can add those two together. You got 5 8s down there, 2 8s up there. You add them together and you get 56, which is the correct answer. That is the efficient way of doing those hard ones. So you figure out how many more you need than 5, because you got your 5 times tables down. Everybody loves their 5 times tables. So you do 5 times tables and then see how many more of that, whatever multiple you need. You want to try again?
Yeah. Hold on. I'm just walking myself through it.
Mm-hmm.
Okay, I see now.
Mm-hmm. Cool. So 9 times 7. So I could do a bunch of 7s and then figure out 14, 28, all that kind of stuff. Or a bunch of 9s, figure out 18, 36, all that kind of stuff. Or just do 5s, right? Trade one of these two numbers. Which number do you want to trade for a 5? The 9 or the 7? Either one. Either one's right.
Let's do 9.
Cool. So the 9 becomes a 5. And so how many more 7s do I need to get to 9 7s? If I'm doing 5 there, how many more will I need?
4.
4. Very good. So now I just add this number plus that number, and I got my answer.
So 5 times 7 is 35.
Very good. 4 times 7?
16.
Mm-mm.
Oh,
2
shoot.
times 8 is 16. 4 times 4 is 16. But what's 4 times 7? So a way to get to figure out what 4 times 7 is again, you can use your 5 times tables and think 7 less. Because that's 1 less than 5. 4 is 1 less than 5. So what is 7 below 35? Or you can just do your 4s. You'd always do that. That's 4 of them.
I caught myself again of what I'm doing wrong. 28.
Very good. And then just add these two together and you'll have your answer. Hopefully that's faster than doing what you were doing earlier. Now, if it's not, the truth is you should memorize it. That's the fastest way. Is memorize them.
Yeah, it's faster. I just think I need to study on my times table
Mm-hmm.
a little bit more because I think that video I sent you goes over that.
Yeah. Yep. Definitely should double check your times tables, but that's okay. You're off to a good start. Just continue to stick with it and you'll get the right answer. All right. Awesome.
Okay.
Cool. Any questions?
No. Could we go over one of these one more time and maybe with like a double digit?
I'm out of time. I got a hard stop at 7. But
Yeah.
before we go, I did want to ask, or 7 o'clock Eastern, what is one thing that you learned from this session? What's one thing? If you look at everything we've covered, what is one, whether it's factorials or series or PEMDAS, what's one thing that you learned from this session?
We'll probably say factorials.
Anything else?
How cross multiply, is that technically what it's called?
This is just carrying numbers. So multiplying larger numbers is what it is. But I mean, this is an important skill. This is going to impact every single question that you see that has more than 2 digits. So getting good at that is pretty key. If you only take that piece away, you're way better than you were before. If you can just remember, okay, this is how I multiply when there's multiple digits.
Okay.
Cool. All right, man. I'm going to text you later. I'll stop this. All right. So great work. It's always best if students can bring questions. That's going to help us out the most, especially when they're multiple choice like this. So you'll notice like some of the questions that we're going to cover today have no answers. This is like a heavier type of studying, right? It's like if
Right.
you have to run a 3-mile race and you practice 4-mile racing, it makes it so the 3-mile race is easier. So those A, B, C, D, that's always going to make your life so much easier. So if you can do it with a fill in the blank question like this, it means you have a really good shot when it comes to those multiple choice questions. All right, can you read number 1 out loud for me, please?
Yes. Baker sells a dozen donuts for $3.99. The cost to make 3 donuts is 45 cents. How much is the total profit on 5 dozen donuts?
Perfect. I love this question. All right. What book is this from?
ASVAB for Dummies.
Okay,
It's got
cool.
$10 on Amazon.
Yeah, ASVAB for Dummies is a pretty good one. They have their own app too. I don't know how if the app charges or not, but I know they have an app. So
Yeah, if you get the book, you get like a free.
free app, free like QR code or something like that. Cool.
Yeah,
Awesome.
then after that, it's kind of like Duolingo. You only get like 10 questions a day.
Cool. I mean, if they're the right questions, that's plenty. All right, I'm gonna time you. Are you ready?
Yes.
Or do you want me to go through one and then you can do 2? You can try 2 on your own.
Yeah, yeah. If we could do that, that would be great.
Cool. Let's do that. All right. So a baker sells a dozen donuts for $3.99. So one of the way I used to teach with Kaplan, right? And Kaplan has like a 4-step process. So one is it's been a while. Identify. No, it is analyze, identify, solve, verify. All right, so what you want to do is you want to look at the question, analyze all the relevant data. So what is important information here? Well, a dozen donuts for $3.99. The cost to make 3 donuts is this much. How much is the total profit? And so this part is identify the question. So analyze the info, identify the question, and then solve strategically, right? So there's a lot of different ways to solve. I know in the past we've talked about solving using process of elimination and that sort of thing. So you can solve at like using that as a strategy, and then verify is just kind of doing a double check to make sure, does this answer make sense given the question that it asked?
Right.
Okay. So what you can do is you can find out the value of 5 dozen donuts pretty easily, right? If 1 dozen costs $3.99, how much would 5 of those dozens cost? You can figure that part out fairly quickly. But what you want to know is the profit for each one. And so these come in different sizes. I'm going to zoom in a little bit on this, even though it's all pixelated. So they come in different sizes, right? One is going to be for a dozen donuts, which is $3.99. So 12 is $3.99, right? You know, you're familiar that a dozen is 12, yeah?
Right.
Okay, cool. And then 3 donuts is 45 cents. All right, and this is to sell, this is to make. And so there should be some profit there, right? If I have 3 donuts at 15 cents per donut, was going to be that 45 cents for 3 of them. I can figure out how much profit there is for each dozen donuts. Does that make sense?
Right. Yeah.
Okay, cool. So what I want to know now is how much does it cost? Like one way that I see to solve this strategically is cost per dozen. Once I figure out the cost per dozen, I just multiply that by 5 and I can get my answer. So how much does it cost per dozen? So if 3 donuts are 45 cents, how much is it going to cost me to make 12 donuts? And so the way I would go about that is thinking, all right, well, 3 donuts is 45 cents. So how many threes do I need to get to 12? How many sets of 3 donuts would it take?
4. 4
4.
sets.
Yep, perfect. So what I'm going to do is I'm going to take this and times both of these by 4. I'll do it in red. And so when I times this by 4, I get the 12, which is what I want. And then 0.45 times 12, or times 4, is going to give me the cost for that dozen. Does that make sense?
Yeah.
Cool. So 5 times 4 is 20, carry the 2. 4 times 4 is 16, 17, 18. So it cost me $1.80 per dozen. Questions there? And it may be a little bit fast, so let's get rid of these steps. Let's just focus exclusively on the cost, right? So if 3 donuts is 45 cents, then 12 donuts is going to be $1.80. And the reason I know that is because I need 4 sets of 45 cents. Do you ever lift weights?
What was that?
Do you ever lift weights?
I do.
You do. You bench press, yeah?
No.
No, not too often. Okay, so well, if you bench press, there's a plate, and those plates are 45 pounds. And so
Right.
usually people who bench press a lot know their 45 times tables kind of quickly. And so you can actually look at this 45 and know that 2 45s will make 90 and 4 45s will make 180. And so that's going to be kind of the same thing. You figure it out and times it by 4, and now you know how much it costs per dozen.
Okay.
All right. So now I need to know the profit. So cost is how much it costs to build it. And then how much do they make? How much does it cost for somebody who's buying that? How much do they sell it for a dozen? Blurry. But it's $3.99 for them to buy it. Okay.
Right.
So now I take the cost, or I'm sorry, the selling price minus the making price, right? How much it costs to make it. And what I'm going to be left with is the profit. Does that make sense, that part?
Yeah.
Okay, cool. So how much does it cost to make 12 donuts?
$1.80.
$1.80. Cool. Good job. And so you just subtract that and you figure, okay, this is 19, this is 2. So $2.19. That's every time the baker sells a dozen donuts, $2 goes into his pocket, $2.19. And so $2.19 is the answer. And they tried to get you to pick that one, but there's one last step. So this is not the right answer. Do you know why 219 is not the right answer?
Because it's asking for what the total profit is on 5 dozen donuts.
Exactly. If I just wanted 1 dozen, 219 would be right. But because I want 5 dozen profit, it's got to be 5 times that. Now, again, you can kind of look at this and make an educated guess. What do you think 219 times 5 would be closest to? Do you think it would go up to $17 or 13 or just stop it at that 1095?
Sorry, could you repeat that last part?
Given that this answer, when we do 219 times 5, is going to give us either A, B, or D, right? Because we already eliminated C.
Right.
Which one do you think makes the most sense? Or is there one that you can eliminate? If you can eliminate one of them, it's just as good.
Probably A.
Why can you eliminate A?
Right off the bat, multiplying 2 by 5 would come out to 10.
Very good. Yep. And so it's a little more than 2, but it's not that much more than 2, right?
Right.
3 times 5 would give me $15, and that's still less than 1770, right? So we know for sure 1770 is going to be too high.
Right.
And so now we have a better educated guess. The answer is going to be that 1095, but let's go through and multiply out to figure that. So what is 5 times 9? And you remember last time we talked about the 1s, the 10s, all the place values. So we're going to practice that again. 5 times 9?
45.
45. So we drop the 5, carry the 4. 5 times 1?
5.
Plus 4?
9.
9. Very good. Well, we don't want to put a decimal yet, but we will later. And then now 5 times 2? 10. Very good. And now the decimal goes wherever it was in the question. So here there's 2, here there's none. So we're going to shift it 2 times. And we get that 1095. Questions there?
I don't think so, no.
Okay, cool. There's a million ways to do this one. There's a lot of different methods we could use to get to the answer, but this is one that's fairly quick, right? We figure out the cost to make a dozen and then just times that by 12. But you can see where mistakes they were hoping you were they would hope that you would pick. They wanted you to pick that 219. All right. Questions? Any questions here?
No.
Okay, cool. Nice. This next one's cool. This one reminds me of algebra for sure. So go ahead and read this one. I'm going to give you 2 minutes. You may not know exactly what to do from the jump, but I still want you to try to come up with some answers, okay?
Okay.
All right, go ahead and read it. I'm going to start the timer as soon as you start reading.
Your piggy bank contains $19.75 in dimes and quarters. There are 100 coins in all. How many dimes are there?
Cool. We're at about 4 minutes. Keep going. Cool. 10 seconds till 5 minutes. So we'll just assume at 5 minutes, you're definitely over time. So just tell me your best guess.
I would probably say B.
B. When in doubt, choose B. I had a recruiter who always said, when in doubt, just choose B, which isn't a bad idea. Cool, not bad. So 5 minutes, 27 seconds. What did you try to do? Like, what was your first effort?
Well, I wrote down on how many coins there are in total, and it says 100. Then I made a side note of how many dimes would equal $1. Same with quarters.
How many dimes would go into $1?
10.
Good. And then how many quarters? Is it 4?
Yep.
Perfect. All right, sweet. And then what?
I think that's where I got lost. I was trying to divide 1975 by 100.
And that's just going to give you, like, it only, because you're just dividing by 1 basically with a couple zeros. So all that's going to do is kind of just shift the decimal place. It doesn't really change anything. But it's a good effort. I mean, you tried something, so that's great. And then you also have some prior knowledge, right? Because that's what the test is checking. It's checking to see, do you have prior knowledge of this stuff? So you use some stuff that you knew. Now, what I did is going to be a little bit different, but it's still kind of similar. I did say that there's 100 coins. So I said dimes plus quarters equals 100. And then I said the number of dimes, right? So dimes times 10 plus quarters times, how much is a quarter worth?
25.
Yep, 25 equals whatever the total was, which is 1975. I got rid of the decimal place because it doesn't really serve me, right? It's a lot easier if I say, okay, I need a number of Q's to give me that to 1975 and a number of dimes. And combined, they're going to give me 100. And then I started trying to do some fancy math stuff, but that's not really helpful here. The easiest way to do this one is going to be to start with the answer. So you guessed 30, right?
Right.
And so that is the number of dimes or the number of quarters?
Dimes.
Dimes, very good. And so all we got to do is check, right? Make your best guess, see if it makes sense, and then we don't have to do anything else. So if dimes is 30 times 10, how many quarters will there be? Times 25. How many quarters would there have to be? If you got 30 dimes, how many quarters?
70.
Very good, because it has to add up to 100 coins total. So
Right.
we know that 70 would be the other answer. And so now we just checked, does this equal that 1975? Well, the good news is 30 times 10 is pretty easy. What's 30 times 10?
300.
300. So that means we only have one real math problem to do, which is that 70 times 25. What is 70 times 25? I'm going to let you do it on your own. I am going to time you for that. Ready, go.
1,750.
Very good. I think that's right. Let me double check it real quick. So these are zeros, right? And then 7, and then we shift over because we're using the tens place now. 7 is going to be that. 35. 7 times 2, 14, 56. Perfect. That's what you got, right?
Yep.
Sweet. Now, what do we know? If we add these two together, is it going to give me that 1975?
No.
Right. And this is where being good with numbers and seeing a lot of questions is really helpful. Because in my situation, what I would do is I would see this 70 times 25, and I would know that the first digit's going to be a 0. Because anything, anything times 10 or anything times 20 is going to have a 0 at the end, right? And so in this case, if you know that it's going to end in 0,
Right.
you know it can't equal 1975. So you can actually eliminate it just a little bit faster. Did you add them
Right.
together and get an answer?
I did just real quick.
What'd you get?
1050.
Yep, 2050, right? 2050.
Oh, yeah, I forgot to add the one. Yep.
Mhm.
2050.
And so is that too big or too little?
Too big.
So does that mean we need more dimes or more quarters?
More quarters.
More quarters will make it bigger. That's the thing. So this is another way, right? If you're really good with math, well, if I had 100 quarters, that's going to be $25. That's the biggest. And if I had 100 dimes, that's going to be $10. That's the smallest. And so the more dimes there are, the smaller the number, and the more quarters there are, the bigger the number. Does that make sense?
Yeah.
So when we get this 2050, we know, do dimes need to go up or do dimes need to go down?
Okay. The dimes need to go up.
Dimes need to go up. Very good. So what are you going to try next?
40 dimes times 10.
Good. What's 40 dimes times 10?
400.
Very good. And then we need to figure out the quarter side of the equation. How many quarters is it going to be?
60.
60. Very good. Nice. You know your pieces of 100 very well, which is good. That helps with percents. All right. So go ahead and do 60 times 25. Tell me what you get. Now, again, I'm going to say the same thing I said last time. When I see that 0 in 60, I know that it's going to end in a 0 here.
Right.
And so I know it can't end in a 75. But let's go through.
I've got 1,500.
Let's see. 30. Yep, that looks about right. $15-ish, 1,500, sure. And so you add that. What is $4 plus $15? Well, that's $19. Too high, too low?
Too low.
Too low because we wanted 1975. So
Right.
we need some more quarters. So we tried this one, it was too small. We tried this one, it was too big. And so what has to be the right answer?
5.
Yeah, C, right? There's only one answer that's in between those two. That has to be the right answer. Now let's prove it. So 35 times 10 is what?
50.
Very good. And then how many quarters? And how many quarters is it going to be?
Sorry, I'm just doing some quick math.
Yeah, dude, do your thing. Do whatever you have to do.
65.
Very good. Nice. A lot of students would guess that wrong. They would guess 25 or 75. Round up incorrectly. And the good news is when you do this multiplication, you can see right off the bat, it ends in a 5. Once you see
Right.
it ends in a 5, you know you're probably right, but you can verify.
Okay, yeah.
What'd you get?
1675.
75. Okay, where'd the 75 come from? So I got 1625. Where do you think the 7 came from?
Okay.
Or where did my 2 come from? Either way. So which number did you put on top? 25 or 65?
65.
Okay, cool. So we'll focus in on this one. First is 5 times 5. What's 5 times 5?
25.
25. So carry the 2, bring down the 5. And then what's 5 times 6?
30. Okay, I see what I did wrong.
Cool. Yeah, you said maybe 35 and then added 2 to get 37, right?
Yep.
Cool. Perfect. All right, so we got 350 over there, 1625 over here. We add them up, and lucky for us, that's what we wanted all along, right? And so we have the right answer. So how many dimes are there?
35.
Very good. Yep. Now I want you to notice that over here I did the same question twice, but I flipped them, right? I did 65 times 25, and then I did 25 times 65. I just want to make it clear that the answer still comes out the same. You still get that 1625, no matter which order you're going in.
Right.
All right. Any questions there?
No.
Cool. All right. And so I know what you're thinking is this took so long. There's no way that you're going to have enough time to go through all of them.
Right.
So what you can do and what I would recommend you do is stay in the middle. If you go to these outliers when you're back solving, you may have to continue guessing. But if we checked both of these and they were both too small, we would know that this one's right. Or if they were both too big, we would know that this one's right. So if you stay in the middle first and then work your way to the outliers, it makes it a little bit easier.
Okay.
All right. But you did fine. Any questions with this question?
No.
All right, cool. So this is a really good one for back solving. There is a way algebraically to solve this, but it's a little bit messier. You know, you can like graph it and figure it all out, but honestly, going through and back solving it is probably going to save you the most time.
Okay.
All right. And then also knowing that it has to be one of these ones that ends in a 5 helps, because that's going to help you to know, okay, that way it doesn't result in a whole number. Because, you know, dimes times 30 or dimes times 40, dimes times 60, that's going to be a whole number. There's no 5 at the end. And so quarters times 30 or 40, that's going to be a whole number too. It might be 350, but it ends in a 0. And so same thing there, you want to incorporate these, one of the answers is going to have to end in a 5.
Okay.
Let's try one more from your worksheet, and then we'll go back over to my proportion stuff and see what we got. So let's go to a higher level one. Let's see what we got here. Lucky number 13. I don't know if I can read it. Give me 1 second. I want number 13. We're going to do number 13, but all right. A little bit more legible, right? Not so pixelated. All right, on your mark, get set. And this one's going to be all you, and then I'll swoop in and help you with it. Ready, set, go.
I got 50 feet.
Great work. This is an easy one. Too easy. But you might find one that's easy like that. So that's great. Minute 19,
Right.
time, right? This is where you get extra time for those harder questions down the road. So you did really, really well. I'm guessing you know the difference between perimeter and area already. Is that correct?
A little bit. Yeah.
Cool. All right. So just
Perimeter's the outside, area's the
mm-hmm.
within.
Yep. Space. Perfect. And then so area you find by multiplying, perimeter you find by adding. And so you did exactly what you're supposed to do. Did you end up drawing a picture? Did you draw it, the 9 by 16?
I did. I always do that because it helps me a lot.
That's exactly what you want to do. You want to draw it out so that you can see, okay, 9 by 16. Now, 144 does exist. It's all these little squares. If I measure 9 here and 16 across here, it's going to be 144 little bitty squares inside of there. And that's the area that the space takes up. But that doesn't have anything to do with how much chain link fence we need around it. And so what
Right.
we need is 9 plus 9 plus 16 plus 16, which I'm sure you did it this way because you like your doubles, 18 plus 32. And that's where you got your 50.
Right.
Cool. Good work. That one's too easy, man. I feel like I'm letting you off the hook. Let's through. This one's got a fraction, so we'll try one more. One with a fraction in it to give you a little bit of a challenge before we wrap up. But yeah, did you have any questions about this one? Even though it is easy, these are actually really good opportunities to focus in and like drill down the details. Any questions here?
No, I guess if I were to have a question, it would be if, for example, if it wasn't a rectangle, if it was a triangle per se,
Mhm.
guess how would we find the perimeter of that? Would the base say 12 and the sides were 7?
Like that?
Yeah.
Cool. So that's easy. Perimeter, you still just add.
Okay. Or I guess I should have said a right triangle with a 90-degree.
Okay. 12 by 7.
Yeah, 12 by 7, and that long edge would be X.
Perfect. So for this one, you got to use the Pythagorean theorem. That's my favorite math thing, right? That's going to be a squared plus b squared equals c squared. And so what you do now to figure, because you could figure out, well, 12 and 7, that's easy chain link part. What you don't know is this x. And so what you do is
Right.
you do 7 squared plus 12 squared and equals c squared. And so we don't know what c squared is yet, but we can get there. So what is 7 times 7? And these, just to be fair, this is a number you should know. You should know your perfect squares for sure.
49.
Very good. What is 12 times 12?
144.
Yep, very good. And what is 144 plus 49?
193.
Very good. So 193 might be a perfect square, but you would then take the square root of 193 to figure out what c equals. Now, what we can do, just because I don't know it offhand, is we could figure out 15 times 15. This isn't going to be enough, so let's try 16s. This one will reach. So 256. All right, sweet. So it's somewhere between, so 15, well, let's do 15 times 15 real quick just to prove it. 25, 50. Oh no, this will go past. Actually, it's going to be less than 15. 5, 225. So it's not, 16 is too big. So it's going to be less than 15 because 225 is bigger than 193. And so less than 15, but probably more than 14. And let's verify that. And so this is 196. And so 196, you can tell, is really close. It's actually just barely over 193. So it's not going to be 15 either. This one's going to be approximately 14, a little less than 14, because 196 is just a little more than 193. So you could say this is close to 14. and then you'd be able to process of eliminate out to see what the perimeter is based on your A, B, C, D.
Right.
But that's cool. That's good for now. It's a good question. Let's finish up with this one. A rectangle is 1.5 times as long as it is wide. The perimeter of the rectangle is 100 inches. What is the length of the rectangle?
How wide it is?
The length.
Yep. Oh, links. Okay. 30.
Very good. Very good work. So 30, 30, 20, 20. And that gives you that 100 perimeter. Not too bad. I didn't time you on it. I should have. But you got it right, which is really impressive. This one's one of those harder questions where you do have to think about it. How did you get your answer?
I was breaking down the perimeter. So, four quarters equals $1. Not $1, 100.
Mm-hmm.
So I was just breaking down my multiples of what would equal to 100.
Mm-hmm.
So considering it's a rectangle, I couldn't do 50-50. Then I ended up getting 60-40, which is what I got with the 30s.
Mm-hmm. Got you. I like it. Not bad. Not too bad. The important question I have for you is, do you realize that 30 equals 1.5, which is 1.5 times 20? Do you like conceptually understand that idea?
I do not know.
Okay, that's
Could
fine.
we go?
Yeah, we can. So what is one? So what is 20 times 1?
20.
Very good. And what is 20 times a half? And this is also known as, what is half of 20? Like, I know you know what that is, but I don't know that you know what 20 times 1/2 is. And the answer is the same, but knowing they're the same and why they're the same is going to be what helps you here. So
I could only see dividing both sides by 2.
Yeah, that's what you end up doing. So anytime you see like 3/5 times 1/2, all you're going to do is multiply straight across. So this becomes 3 times 1 over 5 times 2, right? Same thing here. It's just 20 is not a fraction. So what you do is you turn it into 1. So it becomes 20 over 1, and then you multiply straight across.
So on an equation like this, would you always put a 1 there?
Yeah.
So if it was like
if it's a whole
45,
number, right?
yeah,
If it's
okay.
like 1/2 times 1/3, there's no reason to put a 1 there because it's already set up for you, right? But if it's 5 or a messy 8 times 1/3, well, yeah, it's a lot easier if you put that 1 there because then you have a denominator to multiply across.
Okay.
Dividing a number by 1, like what is 67 divided by 1?
67.
67. It
Oh,
doesn't,
divided.
yeah, it doesn't change the number. Anytime you
Right.
divide by 1, the number stays the same. So that's what you're doing when you add that 1 underneath. You're dividing by 1, so you're not changing the value.
Right.
Okay, so now what is half of 20? Go ahead, you can answer that. If you and I break into a bank, we steal 20 pieces of chocolate and we split it, how many chocolates do you get?
Half.
Half. How much is that if it's 20 pieces?
10.
10, right? So half of 20 is 10. That's conceptually, right? Half of 20 is 10. But physically, what you do is you say 20 times 1 on top and 1 times 2 on bottom. And you end up with 20 over 2. Now, what is 20 divided by 2?
40?
20 times 2 is 40. When you divide, numbers get smaller, just like adding and subtracting. When you add, numbers get bigger. When you subtract, they get smaller. When you multiply, they get bigger. Now we're dividing, so it has to get smaller. What's 20 going to turn into when I divide it by 2?
10.
10. And so this is the part that you're missing in your playbook, knowing how to divide.
Right.
All right. So 1.5 times 20. Well, the 1 is not going to change the 20. It's the half that changes it. So that's where you're going to have 20 plus 10, which is that 30. That's where 20 times 1.5 is 30. And the way you can do it, you broke it down, you see now that half of 20 is 10, 1 of 20 is 20, so 20 plus 10, that'll give you that 30. Now, getting the answer right while not using this piece of information is still impressive. It's still good, but you want to be able to use that information as well. And that's going to help you eventually. But yeah, I mean, for your test, you got the answer right, and you got a test coming up. So definitely use your intuition. That's helping you, but you want to know a little bit more about fractions for sure. You want to know that 1.5 is going to give you 30, because that's 1.5 20s. If you think of like a $20 bill, right? I want 1.5 of those. I'm going to have a 20.
Right.
Okay. But there are technical ways to do fractions. The technical way to do it here is going to turn this into a improper fraction. And so what you do is you multiply and then add, and so you get 3 halves. Now notice that 1.5 and 3 halves are the same thing, right? If you have are you wearing shoes?
No.
Are you wearing socks?
I am.
Okay, cool. So how many socks do you have on?
2.
2. Is that 1 pair of socks?
Yes.
All right. If you had 3 socks, how many pairs of socks would you have? No, 6 socks is 3, right? That's 6 pairs is going to give you 3 socks. 6 socks is 3 pairs of socks. But if you have 3 socks, how many pairs do you have?
1.5.
1.5. That's important. 3 halves is equal to 1.5. 3 halves is 1.5. This is like a fundamental truth. So getting that kind of stuff down is going to help you here and there if you come across fractions. What we're going to do is we are going to do the same thing. We're going to divide 20 by 1. You get 60 over 2, which again is going to give you that 30. So the answer is still the same. That was probably a little too fast. So 3 times 20 on top, 2 times 1 on bottom, 60 over 2, and then you divide to get that 30. And so knowing the different ways to get the same answer is going to be ultimately what helps you.
Right. I think I'm starting to see how.
Yeah, I would tell you that you did better today than you did last time. I think you've been studying a little bit. And I think also working with questions is going to always help you. Like continue to work with these questions, work with the book and get through some practice questions, because getting that familiarity is going to be what ultimately gets you the success. Okay.
Okay.
All right, sweet. All right, Gavin, great work today. If you need me, just shoot me a text. Remember to be kind to yourself and treat yourself as a learner. Are you considering a career in the military but feeling overwhelmed by the ASVAB exam? Look no further than GaminalTutors.com for the best ASVAB prep courses. Our courses are designed by experienced instructors to help you master the best sections of the ASVAB exam, including mathematics, English, and general science. We use proven teaching methods and provide extensive practice materials to ensure that you are fully prepared on test day. With GaminalTutors.com, you'll have access to comprehensive study guides, personalized tutoring sessions, and online practice exams. Our courses are available on demand, so you can learn at your own pace and on your own schedule. Don't let the ASVAB exam hold you back from achieving your career goals. Sign up for GaminalTutors.com ASVAB prep courses today and take the first step towards a successful military career.